Hi everyone, welcome back to our Calculus 3 class notes. We're in our last half page here of the section 15.2. So we're on page 92, right? 92. And this is the last half page in section 15.2 on double integrals over non-rectangular regions. But I just wanted to quickly point out what the properties of double integrals are. So if we have two functions, f and g, both a function of two variables, they're continuous on the bounded region R, then the following properties hold. So this is very similar to what we know about integration already from Calc 1 and Calc 2. If I have a constant multiple, in other words, I have a constant in front of my function, I can just pull that all the way out in front of both integrals here. If I take a sum or a difference of two functions, I can certainly split it up into two integrals, two sets of double integrals. And domination, that property says if I have a function that's integrated in that integral of that function, so the volume of that function or the net signed volume underneath or above that function to the xy plane, if that's positive, if that will always be positive if f is always positive on R, right? Because this represents a volume. Now, if the function is greater, if the integral of the f of xy is greater than or equal to the integral of g, that is true as long as that function f of xy is greater than or equal to g on R as well. Okay, so this is just very simple basic ideas if you just picture what we're finding here, that signed volume. And then additivity, of course, if I break up a region into two separate regions, I can integrate over those two separate regions and add the result together. Okay, R here would be the union of two non-overlapping regions. These cannot overlap, of course, because they have to comprise the entire region R, not more of it, or counting things in it twice, etc.